Okay, so this section is going to look at understanding the AWS environment. This section is going to look at some of the stuff related with security, define the AWS shared responsibility model, define the AWS global infrastructure. These are the topics mostly we're going to have a look. So these chapters will help you map out the lay of AWS land in your mind. You'll learn about how and why AWS hundreds of global distributed data centers are divided into regions, in turns are further divided into availability zones. You'll explore how you can design your own applications to take the best advantage of those divisions. You'll also learn about AWS extend the network reach of your applications to its globally distributed edge locations that make up the front end of CloudFront, Amazon's content delivery network CDN. Finally, you learn how the ways you use and rely on Amazon's resources are governed by the terms of both AWS shared responsibility model and the AWS acceptable use policy. Failing to properly understand those framework will, at best, lead you make expensive mistakes and odds that lead to disaster. So you need to understand pretty much this technology, AWS infrastructures and regions. AWS global infrastructures, AWS, we call it AWS regions. AWS performs its cloud magic using hundreds of thousands of servers maintained within physical data centers located in a widely distributed set of geographical regions. Let's say Sydney, we have the data centers, and AWS resources they are running over there. Sydney, close to Muscat, Alexandria, there's a data centers. As Amazon's global footprint grows, the number of regions grows with it. The documentation page, this one should always contain the latest information available. Global infrastructure means, let's say, Sydney, AWS, they have few data centers. Melbourne, Brisbane, we have some data centers. Also, another country, multiple data centers. Every country, they have the data centers. The current list of AWS regions and their destination designations. US West called US West 2. List US West North California regions, US West 1. In this way, let's say US East, we call it North Virginia region, US East 1, right? That's kind of like a designations we have. They are all region, and each of the region, they have a kind of like a short name. This is kind of like a short ID number or name called designation. So regionally based services, when you request an instance of an AWS service, the underlying hardware of that instance will be carved out of a server running in one and only one AWS regions. This is true whether you are talking about Elastic Cloud Computing, which is EC2 virtual machines instance. It's Elastic Block Store, which is EBS storage volume, a bucket within simple storage service S3 or new Lambda serverless functions. In all those cases, although that anyone anywhere in the world can be given access to your resources, their underlying physical host can exist in no more than one region. Checking your current region should become a second nature reflex, much like the quick mirror checks you regularly perform while you are driving a car. So this one shows the region status and displays at top right on the AWS Management Console page. Basically, this one we have looked at already, right? How to select the region. Default is North Virginia, but let's say I want to select Ohio or Oregon, so I have the options to select. So what's in all this for you? Dividing resource among regions lets you do the following. Locate your infrastructure geography closer to your users to allow access them with the lowest possible latency. Locate your infrastructure within national borders to meet regulatory compliance. Isolate groups resource from each other and from larger networks to allow the greatest possible security. So basically, Yeah, it depends pretty much. Let's say your customer located in UK. So you should use the data centers over there. Then they'll have a faster access. If your customer located in, other region like Melbourne or somewhere, maybe you can use the data centers over there. In this way, they'll have a faster response, faster. Also, compliance issues. Many companies, they have to keep their data in their country. So then if you're living in somewhere in Europe, so you should use the European database or data centers. Those are the options we have from AWS. So globally based services, as a rule, their global status will generally make sense from a structural perspective. So here are some example. AWS Identity and Access Management is the service for managing the way access to your account resources is achieved by way users and groups and roles and policies. So we're going to study a bit more about that. This is provide, you can create username, you can create groups, those kind of things similar to directory services. You can use that one. AWS CloudFront is the content delivery network you can use to lower access latency for your application's user by storing cached versions of frequently requested data at AWS edge locations. CloudFront it's provide one of the services. It's kind of like a cache services. With that, you can redirect your traffic. Let's say if user from UK they want to access some resources from the cloud, automatically this CloudFront will direct them to UK data centers. Or let's say you're purchasing something, but you need to pay to UK. So automatically your payment system will direct over there, that database or that system. If you purchase in here, maybe CDN or we call it CloudFront is a content delivery network, CDN services. So this service can help you globally to direct the traffic. While Amazon S3 bucket must, as we mentioned earlier, exist within a single region, S3 is nevertheless considered a global service. Open the S3 console page and look at the region indicator. So that means even if you create storage account, you can create in particular area. The region indicated on the AWS Management Console pages for each of those services will be global. Now, service endpoints. To work with or access the resources you're running within AWS regions, you will have to know how they are identified. Your developers and administrators will, for instance, want to contact with resources through their applications code or shell script. For each access, they will often authenticate into your account and list and administrate resources and objects by referring to the endpoint that's specific to a particular region and service. For example, the correct endpoint for an EC2 instance in the US East 1 North Virginia region would be EC2 US East 1 Amazon AWS.com. The endpoint for the Amazon Relational Database Services in the EU West 3 Paris region is rds.eu West 3 Amazon. So they are kind of like a endpoint or locations. Each of the locations kind of like a address. For long up-to-date complete list of endpoints for all services, you can go to that locations. For different services, there are different endpoints. See, this is the endpoint. Endpoint is kind of like because many services, but this is their locations, basically. AWS Global Infrastructures Availability Zones. An AWS region encompasses at least two distinct availability zones connected to each other with low latency network links. Although, for security reasons, Amazon jealously guards the secret street addresses of its data centers, we do know that a single AZ is made up of at least one fully independent data center that's built on hardware and power resources used by no other AZ. As shown figure 4.2, AWS resources based in a single region can be requested and run within the AZ region. So this figure represents the AWS infrastructures divided among multiple regions and availability zones. Let's say this is one region. Inside that, we have two availability zones. So we have data centers, availability zone A and availability zone B. In case something happened with A, your resources will be available from B. Region 2, region-based resources, Amazon machine image, AMI. Let's say this is AZ-based EC2 instances. This is also like two data centers we have, but two different regions. So availability zones means they made in such a way that if something happened, it will be available over there. That's how they make, and they are kind of independent. That's why it's possible to break down one, but not two at a time. The one is done, the other one should be fine. Yeah, that's how they design everything. Let's say you deploy one of the virtual machines, but it will be working this way. Now, availability zone designation. So understand how availability works. Immediate and practical. Before launching an subnet associated with an AZ. The subnet is a combination of instances hosted. For now, you should be aware of how AZs are identified in this resource configuration process. So this chapters you looked at Northern Virginia region is described at US East 1. With that in mind, US East 1A would be the first AZ within the US East 1 region, and US East 1D would be the fourth. It's just like location name, right? This one is saying select a subnet and AZ for an EC2 instance. In this exercise, you'll walk through the process of selecting a subnet and availability zone, but you won't actually launch an EC2 instance. Choose the EC2 link from the AWS service menu and launch instance. Confirm that. Region indicator at the top right of the page showing North Virginia. It's just saying how to select the locations. Choose the select button next to the Amazon Linux 2 AMI entry and leave the default T2 micro free tier eligible instance type selected. And hover your mouse over informations to see the subnet item, read the descriptions, then choose the adjoining drop-down menu. You'll probably see around 6 subnet IDs, each one associated with its default AZ. This exercise will not continue on any further with the instance launch process. So you can choose cancel or abort. Nothing will have been launched and you'll incur no cost. This one we going to have a look. Availability zone networking. You'll only get the full value of the resources you run within an AWS region by properly organizing them into network segments. You might, for instance, want to isolate your production servers from your development and staging servers to ensure that there is no leakage between them. This can free your developers to confidently experiment with configuration profiles without having to worry about accidentally bringing down your public-facing applications. Distributing production workloads among multiple subnets can also make your applications more highly available and fault-tolerant. A subset is really nothing more than a single block of Internet Protocol addresses. Any compute device that requires network connectivity must be identified by an IP address that unique to the network. The servers or other networked devices that are assigned an IP address within one subnet are generally available to communicate each other by default, might have traffic coming through and or subnet restricted by firewall rules. So all these IP address, subnet, network, they will be also part of this availability zone. Private networks, including AWS subnets using the IPv4 protocol, are allowed to use all the address within the 3 address range. So this is the IP address range available, like 192.168.0.0.2, 255.255, and 172.16.0.0.2, 172.31.255.255. So this is private IP address range. Yeah, this is called classless interdomain routing. They are kind of like a private address. So when you configure AWS instances, automatically IP address will be assigned from this subnet automatically. Let's say you create one of the virtual machines, automatically it will get the IP address from this range. But if you want, you can make changes, but they have these stuffs automatically. Now, availability zones and high availability. One of the key principles underlying entire business of server administration is that all hardware will eventually fail. It may be an important router today or a storage volume tomorrow, but nothing can last forever. And when something does break, it usually takes your application down with it. A resource running without a backing up known as single point of failure. The only effective protection against failure is redundancy, which involves provisioning 2 or more instances of whatever your workload requires rather than just one. That way, if one suddenly drops off the grid, a backup is there to immediately take over, but is not enough to run parallel resources if they are going to be sitting right next to each other in the same data center. So that would not do you a lot of good in the event of building white blackout or malicious attack, leaving your backup just as dead as the instance it was supposed to replace. So you'll also need to distribute your resources across remote locations. In this context, it really makes no difference whether your workload is running in your on-premises data centers or in the Amazon cloud. In either case, you'll need resource redundancy that's also geographically parallel. So what is different is how much easier and sometimes cheaper it can be to build resilience into your cloud infrastructure. Now, since the AWS cloud is really available within dozens and dozens availability zones, Apple's continents, deploying or list or at least preparing quick launch templates for remote backup instances easy. And since AWS workloads can be requested launch on demand, the job efficiency provisioning parallel resources is built into the platform's very DNA. The configurations and automation steps can be a bit tricky, but developers and administrators to figure it out, they are one who look and pass the AWS Solution Architect Associate certifications. You should at least be aware of AWS slays the applications failure dragon using auto scaling and load balancing. It's talking about two things. One is availability zone. Availability zone means like inside one region, you have two zones. If something fail, another one will work. That's one kind of availability zone we have. And high availability means which we can configure. Let's say particular week, maybe a lot of people like holiday and other stuffs, many people watching movie and stuff. So that time maybe your movie, maybe that server may be hosting in AWS, so that needs more um, resources. So with the auto scaling, automatically more resource can be added. Or load balancing means maybe many people jumping to your applications, then your applications will not respond as expected. That kind of scenario, we can create load balancing. Some people may be direct to this server, some people to direct to secondary servers. In this way, we can do the load balancing. So with the high availability, also we can make our service available all the time. So combinations of availability zone and high availability, we can provide highly available services. Now, AWS global infrastructures, edge locations. The final major piece of AWS infrastructure puzzle is its network of edge locations. An edge location is a site where AWS deploys physical server infrastructures to provide low latency user access to Amazon-based data. That definition is correct, but it does sound suspiciously like the way you'd define any other AWS data center. The important difference is that garden variety of data centers are designed to offer full range of AWS service, including the complete of EC2 instance types and the networking infrastructures customers would need to shape their compute environments. Edge locations, on the other hand, are much more focused on a smaller set of roles and will therefore stock a much narrower set of hardware. So what actually happens to the edge location? So you can think of them as frontline resource for directing the kind of network traffic that can most benefit from speed. Edge locations and CloudFront. Perhaps the best known tenant of the edge location is CloudFront, Amazon CDN service. How it works, let's say you are hosting large media files in S3 buckets. If users would have to retrieve their files directly from the bucket each time they are requested delivery, especially to end users living continents away from the bucket locations, it will be slow. But if you could store cached copy of the most popular files in the server located geographically close to your user, then it will be faster, right? That's the CloudFront. So edge location means that which particular locations we should provide the services, and we can do this one with the CloudFront. So Amazon Route 53. Route 53 is another DNS services. Amazon Domain Name Service Administration tools for managing domain name registrations and traffic routing, AWS Shield, a managed service for countering the threat of distributed denial of service attacks against your AWS-based infrastructure. AWS Web Application Firewall, a managed service for protecting web applications from web-based threats. Lambda Edge, a tool designed to use serverless power of Lambda to customize CloudFront behavior. So all this talk will make more sense. We suggest you explore the configuration process of a CloudFront distribution by following exercise. So is a AWS Web Application Firewall. This is the services we have. Then Lambda at Edge, this is another service we have. Yeah, Amazon Route 53, which is the DNS server. So these are the services we have in the edge locations. This exercise is showing, take a quick look at the way CloudFront distributor configure, choose the CloudFront link from the AWS service menu, choose create distributions, and then choose the get started button underneath of the web distribution section, select a delivery method for your content page. Once you are on the create distribution page, choose inside the box next to the origin domain name item. If you have any content, it should appear as an options. Either way, since you are not planning to actually launch anything right now, it does not matter what if any value you enter. Scroll down the page notes for instance distribution settings sections. This price class drop down arrow to see available options for the scope of your distribution. Note the distribution settings of the bottom page. When you are done exploring, choose cancel to ensure do not actually launch anything. This is just showing the how CloudFront distribution works. This is the locations we can check. So we're going to look at this one later on. Regional edge cache locations. In addition to the fleet of regular edge locations, Amazon has further enhanced CloudFront functionality by adding what it calls a regional edge cache. The idea is that CloudFront served objects are maintained in edge location caches only as long as there is a steady flow of requests. Once the rate of new request drops off, and objects will be deleted from the cache, and the future request will need to travel all the way back to the origin server. Regional edge cache locations, of which there are currently 9 worldwide, can offer via compromise solutions. Objects rejected by edge locations can be moved to regional edge caches. There are not as many as such locations worldwide, so the response times for the many user requests won't be as fast. It's just saying that they have around 9 worldwide locations. They have this kind of like a cache servers. Because of that cache server, service will be provided faster. By design, regional edge cache locations are more capable of handling less popular content. Now, AWS shared responsibility model. AWS Cloud, like any large and complex environment, is built on top of a stack of rules assumptions. The success of your AWS projects will largely depend on how well you understand those rules and assumptions and on how fully you adopt the practices that they represent. The AWS shared responsibility model is a helpful articulation of those rules and assumptions, and it's worth spending some time thinking about it. Amazon distinguishes between the security and reliability of the cloud, which is its responsibility, and the security and reliability of what's in the cloud, which is up to you, the customer. The cloud itself consists of physical buildings, servers, network, hardware used by AWS data centers. AWS is responsible for making sure that locations are secured, reliably powered, properly maintained. AWS is also hooked for patching, encrypting, and maintaining the operating system and virtualization software running its physical servers and the software running its managed services. Shared responsibility means they're going to manage their part properly. Let's say we talked about this morning about all these areas. This is service provider, their responsibility. Maintaining the physical data centers, all the hardware and etc. Yeah, in here is saying customer responsibility is all the data, but AWS responsibility is the hardware part, network part, uh, AWS global infrastructures, and hardware security. This is their, they will be responsible for that. Now, managed resources, a cloud service will hide all or some of the underlying configurations and administration's work, need to keep things running, leaving you free to focus on the business or project. For example, an application running EC2 instance might need a database in the backend. You could install and configure a SQL database engine on the instance itself, but you'll be responsible for patch updates and all regular care and feeding. Alternatively, you could point your applications to a standalone database you launch on Amazon's Relational Database Service, RDS. AWS is responsible for patching an RDS database and ensuring its data is secure and reliable. You only need to worry about populating the database and connecting it to your applications. RDS, therefore, is a good example of a partial managed service. So how would the next level of managed service work? So look no further than Elastic Beanstalks, which hides just all about complexity of its runtime environment, leaving nothing for you to beyond uploading your application code. Elastic Beanstalk, it handles instance storage, database, network headaches, including ongoing patches and administration invisibility. So they manage servers, database, storage, everything. Okay. So you just deploy your application to Elastic Beanstalk over there. This is called managed resource. Managed resources means they're going to manage this one for you. And unmanaged resources means the most obvious example of unmanaged is EC2. When you launch your EC2 instance, basically, you're going to manage this one. So even EC2 cannot set to be entirely unmanaged, since the integrity of the physical server and host it is, of course, responsibility of AWS. Think of it as a sliding scale rather than a simple on-off switch. Some cloud operations will demand greater involvement from you and your administration team, and some will demand less. Use these simple rules of thumb. If you can edit it, you own it. The key, especially during a project's planning stages, is to be aware of your responsibilities and to always make security a critical priority. Service health status. As part of its end of the bargain, AWS makes regularly updated region by region reports of the status of its service publicly available. Any service outage that could affect the performance of the workload will appear in the Amazon's health dashboard, which is status.aws, this one. While configuration errors are always possible cause of failure in your infrastructures, you should always make the service health dashboard one of your first steps whenever you dive into a troubleshooting season. So service health, in here, you can see whether any update is happening, whether any issues is happening, you can check. So if I click here, it's similar to Microsoft also, we have a help, right? That sections. No recent issues. Okay. Schedule changes. Yeah. Lambda plant lifecycle event upcoming. This is the location, this is the time something is happening. Lambda is one of the services. Yeah, it's called serverless applications you can deploy, and you don't need to think about servers. That's one of the services they're providing. So it has some issues, like they're going to plant lifecycle event, like they're going to update or they're going to do something over there. You can see many different logs in here. Yeah, this is old. This is last year, but everything is closed, completed, something like that. But this is upcoming. After 6 months, it will happen. But now you got the notifications about that. That's huge. Now, AWS acceptable use policy, because there is so easy to scale up cloud computing services are powerful tools for accomplishing things no one had even dreamed for just a decade ago. But for the same reason, there are also potential weapons that can be used to commit devastating crimes. AWS acceptable use policy makes it abundantly clear that it does not permit the use of its infrastructures in any illegal, harmful, or offensive way. Because maybe people logged in and after that what they are running, that's also important. Amazon reserves the right to suspend or even terminate your use of its services should you engage in illegal, insecure, or abusive activities. Even running penetration testing operations against your own AWS infrastructure can cause you trouble if you don't get explicit permissions from Amazon in advance. Penetration testing is one of the security testing, but you need to get permissions, then you can do this one. So pretty much this chapter is all about uh, high availability zone, and how to provide high availability, how to use CloudFront. CloudFront, with that you can distribute the traffic to the closer locations for the user. And these are the other small features we have looked at in here. Okay.